2, we're going to be learning about factorial notation. Let's consider the first example. How many ways are there of arranging 5 different books side by side on a shelf? So let's treat this as one of those word questions that we were talking about in day 1. So if we have 5 different spots to put books on a shelf, we have 5 books that could go in the first spot, 4 in the second, 3 in the third, 2 in the fourth, and that leaves us with only one choice for the last spot. If we evaluate this, we get 120. Now in this unit, it's often useful to use factorial notation, which makes writing something like 5 times 4 times 3 times 2 times 1 easier. So factorial notation works like this. 5 factorial. It's like exciting, it's a question mark. And it means 5 times 4 times 3 times 2 times 1. So wherever you start, you're decreasing by 1. So for example, if you had n factorial, this would be equal to n times 1 less than n, times 2 less than n, 3 less, etc. And you always stop at 1. So for example, evaluate the following. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And this will equal 5,040. Many calculators have a factorial button. It's up to you to find yours. On the TI-83, I believe it's under the math functions. So let's shortcut this one, pretending like you found your factorial button. 362,880. So those are pretty straightforward. You'd probably never run into a question that easy. Let's look at something a little bit trickier. So what about 10 factorial over 7 factorial? So 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, I'm just going to leave this over 7 factorial for a second because I want you to notice that this right here that I'm about to highlight, 7 times 6 times 5 times 4 times 3 times 2 times 1, is actually equal to 7 factorial. So I could just write this as 10 times 9 times 8 times 7 factorial all over 7 factorial, and at that point they can cancel. So it makes it easy to evaluate because this right here we would need a calculator for, but if we simplify it using factorial notation, it becomes something we can do in our head. So 9 times 8 is 72, times 10, 720. For number 4, this is 52 times 51, and if I were to continue doing 50 times 49, I'd be doing 50 factorial. So I'm going to skip a step that I did in number 3. All over 50 factorial. We have some canceling, and now we just evaluate 52 times 51, and don't think I have that actually worked out. I will leave it as 52 times 51. Hopefully you have a calculator with you. What about this one? 37 factorial is 37 times 36 times 35 times 34 times 33, and I want to stop at 33 and leave it as 33 factorial. That way it will cancel with 33 factorial in the denominator. And so now I would just need to evaluate 37 times 35 times 34 times 37 times 36 times 35 times 34, all divided by 4 factorial. It looks like I may have an answer for that. 66,045. Okay, let's try some that are a little bit more challenging. So simplify the following. So now these are more algebraic and no calculations really involved. So n factorial over n minus 2 factorial. So if we went back up to the beginning for a sec, you would see that as we expand n factorial, we always decrease by one whole number until we get to 1. So if we're down here, and I need to simplify n factorial, this is n times n minus 1 times n minus 2, and I could keep going times n minus 3, etc., or I could just leave it as n minus 2 factorial. That way, like in the other questions, it will cancel with this denominator of n minus 2 factorial. So your most simplified answer would be just n squared minus n, or you could leave it in its factored form. One more. N plus 3. So what comes next? If I subtract 1, I have n plus 2, n plus 1, and then n. I will stop here, leave it at factorial, so it cancels with the denominator of n factorial. And you could just leave it like that, n plus 3, n plus 2, n plus 1.